So Tim, you were one of the first people involved at ResTech. Can you tell us a bit what it was like back in that day?
Yeah, I was one of the early ones. I wasn't one of the first. I joined the company, probably had about 4 or 5 years, but it was very much like a little startup. It's nothing like it is now. We had about 6 people, and I sort of joined as a managerial role sort of thing. But I knew everyone because we'd all been at uni for too long. And it's actually the people that were there originally are still here. We've still got Steppo and Adrian and people like me. Robin was one of the early ones, so a lot of the original faces are still there. It's very different to what it was now, though. We didn't have laboratories or space. My office was actually like this concrete bunker. It had a concrete column that supported the next floor. I had no windows. It was very different to the office space we've got here now. But it was fun. It was sort of like being in a little startup, but that makes it hard too because you've got no money and you've got to beg, borrow and steal, so we're pinching stuff out of electrical engineering and things like that. But there was some early stuff that was pretty impressive. We won a big prize in Tasmania for the Engineers Australia for the neutral monitor stuff that Steppo was working on at the time, and Eric, one of the early academics. Yeah, so it was pretty good, but one thing sort of led to another and sort of started to grow. It was hard because both Ampcontrol and the university didn't really know the value in it, and so both sides were learning. Pete Cockbain and Alan Broadford obviously had a fair bit of vision when they thought of it, that this link between academia and industry would be viable, but we were sort of feeling our way, so it was a bit hard. Both sides sort of had to learn.
So all that technology that we gathered over the years, how has that changed how we do things here?
I don't know whether the technology we've gathered per se, the technology certainly changed. I mean, back when I did the HSC, there was no calculators, like we did it with pen and paper. When I graduated uni, we only had the very first PC, there was no DVDs, CDs or anything like that. It was all very different. Your reports were handwritten. So technology sort of changed. The fundamental principles didn't, but what you can do with it and how far you can go and how accessible it is what's different. So the stuff that we design now, the functionality that it's got is so much better, more advanced, more maintainable than what we ever did. I mean, the very first electronics, it was just simple looping executives, and there was no Ethernet stack and connectivity. You were lucky if the thing had a blinking light on it. But it still did cool stuff, like earth leakage or whatever it was. But so I think we haven't gathered the technology, we just harvest it, we do it better. It's never the same. The principles and the tools we've got get better and better, but the principles don't change. So electricity still flows in the loop. Diodes still do diode things. It's just, we haven't got the first principles stuff. We build on bigger blocks. I think that's what the difference is. Yeah, so the way we used to do things, it was just more manual. It was harder. We would wait months for a data sheet to come from, National Semiconductor in the US or from a Chinese fabricator or something. We had no internet. There was no email stuff. So things have changed significantly from when I started engineering. And then ResTech's just a part of that, right? So some of the things that we had, the capabilities the power supplies and the instrumentation had were nothing like they are now, but you still had them. It just didn't allow you to go as far. There was still switchgear. It just didn't have, touch interface would have been buttons and things like that. So that's probably the main difference. The technology enables the product to do so much more, or us to build on other people's things, whereas back then you might have had to, you could only do what you could add to it, whereas now you can start with a block that's got a whole heap of engineering in it and rely on that. So that's the difference, I think.
So Tim, what value is there in the student placement programs and the graduate mentorship that we do through ResTech?
It's hard to place a value on something that's actually fundamental. So if you want an actual number, then maybe it's priceless. Someone, put up with my incessant questions and taught me and mentored me. So part of it is, well, you do the same. You pay it forward, etc. But you're not being altruistic. It's not through the bottom of your heart. It's actually the fabric of engineering. The best engineering teams are not the ones with the most experience. The best engineering teams are the ones with diversity. In fact, it's really nice working with experienced engineers. It's really easy because they've done it before, they've seen a problem, and before you make all this progress. But it's really easy to then just do it like you did before. So you miss the innovation bit. Whereas when you've got diversity and younger people or less experienced people in there, then you've got to explain. So that triggers something to review or reflect or go back and ask those really simple questions. So innovation comes from the really simple ones like how or why. And it's harder to ask those when you've done it before. So a really good engineering team has diversity. It's got different skill sets, different ages, different backgrounds. Like we have here, we've got older people that have done a lot. Steppo, me, Adrian, there's quite a few of us around. And then we've got younger people. And mentoring, the student placements and things are not part of, you just have to do it, or, to make sure engineering's always got another engineer. It's actually the fabric of engineering, because it's adding to it. It's not like it's a chore, it's actually you need it. So the most powerful teams are the diverse ones that have all of that experience. And like I said, some of the biggest innovations or light bulb moments I've ever had have come from that really simple question. Why do you do it that way? And that's often what younger people ask or less experienced people ask. So that makes innovation easier. It makes it better. Sometimes it's actually harder to be innovative when you're surrounded by really competent people that have done it before, because then it's just so easy to do the same thing again, and you don't get a different answer. So I think the value of it is priceless. It's what engineering actually needs. It's what good engineering is. It's not a chore.
So you did touch on this before, but all of the technology is really rapidly improving and changing. What advice would you give to young people that are wanting to enter the engineering workforce?
I think if you acknowledge that all the technology changes, then the best bit of advice is actually embrace that. So you can't actually stop learning. You need to continuously learn. So when I started, uni and school didn't teach me how to use a modern computer or an Ethernet stack or anything. I had to learn all of that. So I think if you accept that you need to accept change is going to happen, there'll be new technology. So rather than be scared of it or resist it, you actually want to embrace it, which is exactly what like a graduate does. You start off, you don't know something, there's no pressure, you're not expected to know something, you can make a mistake, you're not going to get in trouble because that's how you learn. And you actually need to keep that, because if you don't have that, then it becomes scary. You can't learn. Like old people have to make mistakes too. It's not restricted to just young people doing that. That's how you learn. So I suspect the primary advice is to actually don't stop being a graduate. So have the same approach continuously. Teach yourself to learn. Don't be scared of making a mistake. Ask a stupid question and don't be embarrassed by it, because that's how you learn. So I think if there was an advice, it's do that. And the only other one is, the youthful enthusiasm is a wonderful thing. You've got it naturally, right? And so you want to try and hang on to that. So somehow when you're young, you don't think of failure. Failure is not an option. It doesn't come up, right? You've got no idea how you're going to do something, but I'll give it a go, The first time you got in a car, no idea how you're going to drive it, but I'll have a go. It's the same thing, I think. So you want to keep that curiosity and youthful enthusiasm, and it just gets a bit balanced by the reality of, well, actually, maybe I'm better off in assessing risk, but you need to keep that. So don't lose it. You want to stay a graduate, basically.
So Tim, we found some old pictures of something that you worked on a very long time ago.
Really?
Do you want to explain some of this stuff to us?
Were there actually photos of it? So I think what happened was a couple of the guys, this is a wire wrap board. So back when I was young, doing a printed circuit board, you actually did it with tape, and you exposed a copper clad thing that had a photoreactive layer on it, and you used to etch the copper off with acid. And so you do this artwork to do it, so the layout sort of thing. And of course that was really laborious, took ages and everything else. So the shortcut was to do what was called wire wrap. So you had these pins and these wires, and you put it all together, and you could wire up a digital or analog circuit with it. So this is one of the early this is a very early a programmable logic array. They were amazing things at the time. You couldn't, how that came about, I have no idea, but it was incredible. Anyway, the guys were dumpster diving over the back of electrical engineering because they were throwing all this old stuff out, and I think they found this one, and see here, it says, please return to Tim Wylie. So that's how they knew it was mine, right? And then there you go, it proves I actually did electronics at one point. But yeah, so this one's an EEPROM, so you used to have to erase it with ultraviolet light, then you'd program it, and that was the way that you could then, bootstrap the system up. But of course these were really valuable, and there was only a few of them, so they were like gold. If you had your own EEPROM, no one's getting that. That was a big deal. So of course that's why it's got Return to Tim Wylie. Yeah, so this is it's a 386, so it's basically a very early version of one of the personal computers. Obviously some sort of memory would have done all the decoding and stuff for that in the programmable logic array. And then that's a card that went into a 9-inch rack. So a very early homemade PC, probably.
Well, Tim, it seems like you've got a pretty good handle on collaboration in the workforce. So I'd like to present you with our Handle on It award, if you're willing to accept it.
Do you know the story behind this one?
I do, but tell us.
Oh, you know the story?
I do know the story, yeah.
I actually built this this trophy, and it was Webbo who had the idea of, if you got a handle on it, because we think about engineering. But actually, I don't think I've ever had it awarded to me. So.
Congratulations.
There you go, yeah. But it was built a long time ago, a bit of cedar out of the workshop. And it was for a different engineering business we were working at the time before we joined ResTech. So it's carried along since then. There you go.
One of the best parts of our staff meetings
is who's got a handle on it. Yeah. It's a lovely idea. Yeah. Thank you.